So this is electrical energy and power, and here is reflection. What is reflection? How we combine resistors. So this thing you're going to understand in first year of your graduation. What is this? Tell me. Have you seen this image or this kind of thing ever before? First year of graduation. Tell me what is this, if anyone knows so. And maybe you use this thing in your practical lab also. Breadboard, exactly. Why we say this is, I mean, why this name is breadboard? Why not anything else? If anyone knows, please tell me also. I want to know this. Pores. Okay. So bread have pores? Oh, you asked first. Remains. Always important. Okay, breadboard is maybe because this is this having holes like it is having holes like in the bread, obviously, and we going to connect the resistor, the capacitor, and we going to make small circuit to do the experimental thing and to see whatever we are learning, whatever we are saying in a theoretical way, that is applicable or not. Okay, so first year of graduation or science lab, or you can say experiment lab. So why should I mean, how this is going to be related to this? See, maximum number of times you have seen if you did not connect this resistor in series or you connect in parallel, so that is going to be burn or that is going to be blast. Did you do that? I do that in my class time, in my graduation time, so many. I just, you can say, fuse this capacitor so many times. Because the capacity is low, and I just attach the wire in a deliberate time or more amount of time, so that is going to be blast or fuse. So whatever like electrical energy is going to convert it to heat energy, or there is a electrical energy, there is a power, this is everything. So that particular everything we're going to see in this. Is it clear, everyone? So that is just to make you curious, nothing more than that. This is your capacitor, this is your resistor. Okay, this one is resistors. You remember the color code or thing? Okay, this is your resistor, or this one is your capacitors. I hope and I believe you remember what is a capacitor and what is a resistor, and how you can find the resistance of a resistor with the help of a color code. Is this clear, everyone? If you have any question, doubts, you can ask me. If you not, so we can move ahead. That is not a big thing. Clear now, everyone? Just a representation where we use how it is going to be converted from normal electrical energy to this, what it is? I mean, electrical energy going to be converted to heat energy, into power, into light energy, and so on and so. Okay, this is the page. This is your, what is an electrical energy? Okay, suppose, first of all, how electrical energy is going to be connected. Because with this particular battery, we have a potential difference. What it is in general? It is a potential difference, PD. So due to this potential difference, when it is going to be greater than 0 in time t, the charge Q travels from point A to B, and due to this flow of charge is the electric current flow. I mean, basically electric current is the flow of charge. So due to this, the power or energy, okay, first of all, let me see, because it is going to be given in the power and so and so. Yeah, so I'm not going to teach you separately. So just a minute. So what is energy? I mean, why we need energy in this particular power thing, in this particular potential difference thing? First of all, to move a single unit charge, we need to do some work, right? That is, you understood? That is the definition of electric potential. You remember or not? I mean, I need to write this thing. Tell me, did you guys remember this thing or not? What is the electric potential or potential difference? Tell me beta, electric potential or potential difference. This simple thing. What it is? Tell me anyone. You tell me, Noel. What is electric potential or potential difference? You can speak up also. You don't need to write anything or everything. Because from there every story is going to relate, like why we need energy and where from it generates energy.
It's about voltage.
What is voltage? That's what I'm asking.
Potential difference simply means like going from low to what is it?
Okay. You tell me, Harimesh, what is electric potential? Don't give me the bookish language. I never ever want. It's a simple thing. It's very simple. Then,
Sir, it's the work done to move one unit charge from one point to another.
See, potential difference is simply B, which is W by Q. Everyone got it? What is the meaning of that? For a unit charge, to move unit charge from any particular point A to point B is going to be potential. Now for single point, because there is a difference. So what is the meaning of difference? Suppose there is a point that is not going to be visible to you. Okay. Suppose there is this particular point A, or there is this particular point B. I need to find the potential difference between this. So to move a charge, unit charge from this positive end to A, and then from positive end to B, suppose this is your O. That is your potential, and this is the potential difference. Means to move a unit charge from two particular point and the difference between them of a potential. Why should I tell you why should this is written over here? Because in doing so, you require work. And whenever you're doing work, there is a requirement of energy. Clear everyone? Whenever we do some work, so if you are not energetic enough, suppose you are not eaten a food, any kind of food since last 2-3 days or last 2 days only, and I wake you up and I'll order you to run 2 kilometers or a single kilometer or 500 meters. So are you able to do that? Because you don't have energy. So the work done and energy is vice versa. So if we don't have potential, or so we are not able to do the work, and in the same way, if we don't able to do the work, so we are not energetic enough. So the energy is not going to be there. So the origin work done to move charge from one point to another is called potential difference. It's called electric potential, not potential difference. In general way, we say that whenever, good question. I tell you na, see, from the beginning point to particular point A is VA, potential till particular point A, VB, potential till particular point B, and PD, potential difference VA minus VB, if I am going in a this way. If I am going in a reverse way, so potential difference is whatever the higher is. You can say here in this way. Okay, in the initial, this is your first case. In first case, clockwise, that is going to be VB minus VA, because I mean it can be negative, but maximum number of times we represent in a positive way. Okay, if I am going in a anti-clockwise, this is your anti-clockwise. So then potential difference is VA minus VB. Now, in general, electric potential states that to move our unit charge from infinite to any particular point P. Okay, reference is infinite, very, very far away. That is electric potential. Sir, is it higher or lower? Which one? Electric potential or potential difference? See, potential difference is nothing but the difference of two electric potential between 2 points. As simple as that. Obviously, it is going to be lower because it is different. Suppose I have electric potential to this point is 20, to this point is 30. So then the difference is 10 only. In reverse also it is minus 10 only. Is this clear? Is this clear, Jyotna? Okay. Simple difference. Like difference is here is a subtraction. Simple. Nothing physics behind it. So where electrical energy originates from itself, like the moment we attach a cell or a battery, because that particular battery do a work, and whenever it is doing a work, so that particular work is stored as an energy. And maybe you are lucky enough to listen this line ever before, or if you are not, so you can listen right now. Is electrical potential energy and EMF the same? Electromotive force? No. Electric potential and EMF is not same. EMF is due to the charge moving in a magnetic field. This is charge itself moving, simply. Okay. Any other question? Yeah. So where I was again. Oh yeah. So the moment in any particular circuit we attach a cell or a battery, so at that particular moment charge starts flowing, and that particular work is stored as a potential energy. Okay. In general, I teach this line so many number of times. Potential energy is nothing but the negative work stored in any particular system. You remember this or not? Tell me first this thing. If someone is not understanding this point, so just make clear here. Potential energy is nothing but negative of work done stored in any system. Simple. Okay, you can see this in previous lecture of mine, and in the end, if time is remaining, so I'll let you know how. So in this, I can teach you also. Okay, so resistors used in the LED transistor in real life, correct? Resistors is used for driving voltage. That is not driving. Okay, so here we need electrical energy, like electrical energy conversion of light energy, electrical energy in the conversion of heat energy, electrical energy in the conversion of so many things. But small these things, simply few examples we can add on more. For example, electrical energy to heat energy. Okay, and then electrical energy to LED and transistor. This is basically electrical energy to light energy. They want to say that PPT creating. Resistor is used to driving the voltage, means with the help of resistor we can create the energy and power also. Or if n number of any other use of electrical energy you can add on, so go ahead. This is just real life connect. The main thing is here, electrical energy formula, where we get from VIT or H equals to I. I mean, they let me tell you this first, and then I'll explain everything. Electrical energy is converted into heat energy, and it is VIT first, I square RT, if I'm not wrong, just Ohm's law here, and then reversing this. Okay, you can put I equals to V by R also. So there is V square on RT. I mean, we going to explain how I write this and from where we reach till this. VIT is just explained here. Okay, so heat energy, or instead of heat, because in books you can find heat. Here it is written over unit or electrical energy. So these are just some formula. Then we have the formula of power, which is energy into time, or energy per time, energy per unit time. Okay. So just divided with the time, so we can get power, which is VI, which is V square by R, which is I square R. Is this clear, everyone? So these are some important formulas, and this is from Ohm's law. I gave you beforehand because we're going to derive this. Is this clear, everyone? And these are the main formula. This we're going to use. Is this clear, everyone? Because this is more a theoretical language instead of more a numerical one, or more you can say. 1 minute, sir. I will copy. Yeah, you can. Don't worry. I'm going to explain. I'm not going to skip. See, let's say a potential energy at point A denoted by UA, while the potential energy at point B is denoted by UB. So UA is Q into VA. What it is? As I already told you, potential energy is stored as a work done. So you can just write it down with the formula work done to reach particular point A. WA you can write. It's UA, and that is WB you can write UB. That is Q into VA, Q into VB. As simple as that. Let's change in the potential energy denoted by U net. I mean, there is a final potential energy means initial potential energy, and that is net, total potential energy. Change in the potential energy. So U net is UB minus UA, which is Q into VB minus Q into VA, which is change in charge and then V. Now introducing the concept of current, because we know I equals to change in charge per unit change in time. So instead of del Q, what we can write I in del T. Okay. So from there we get this U net, which is the total or net energy, net total, or you can say net electrical energy. Electrical energy, and that is I. You can write negative sign also, but negative sign just representing the stored. I mean, it is going into the system. I into del T into V. If T1 is 0, means initially we took time 0, and T2 is some 3 seconds, or just put T. Okay. So what it is going to be? Del T is going to be T2 minus T1, which is T. So therefore, beta, electrical energy I can write E in books. Somewhere it is written over H, heat energy. I mean, this electrical energy converted into heat energy, and that is VIT. Simple. Till now, if you have any problem, questions, you can ask. Other than this, how this work done is treated as a potential energy or stored energy, because I can teach, but this is not the time right now. In the end of this session, is this clear, everyone? Everyone, is this clear? Especially Mario Royal. You seem nothing is going in your head. Is this correct or not? That's why I'm saying because the moment I surface, I can predict it. Good in psychology, but because I am teaching since last 2, 3 years or 4 years. Clear? Vishwanath sir can explain it again. Last one about why not beta? That's why I'm here. See what I'm saying. Potential energy can be treated for any particular system. I'm talking about system. For potential energy can be treated as a work. That means, just simple example, if you take your pen like this, and from the ground you take this particular pen, or you put that particular pen at some height h. So now you have potential energy in this pen, which is mgh, due to this mass, due to gravity, due to height. But in doing so, you need to do some work. So this particular work done is stored as a potential energy. Same thing I'm saying here. Work done in moving from a charge from one particular point to any other particular point is treated as a potential energy. This particular potential energy in electrical circuit, in electrical system, is known as an electrical energy. That can be converted into heat energy also. If I in my electrical instrument, for example, electric iron, and turn on that particular electric iron for a few minutes, for a few hours also. Okay. For example, electrical rod, for which with the help of which you can warm your water or boil your water. Okay. So that is nothing but the electrical energy converted into heat energy, or simply that is electrical energy. That is VIT. How we come to this particular point? Again, because potential energy for electrical system is Q into potential, which is charge. To find the net or total energy, I need to subtract final potential energy minus initial potential energy. When I do so, so potential is going to be V, which is VB minus VA, and then Q is going to be del Q. Now I know this I is del Q by del T, so I put this del Q equals to del Q by del T. I mean, in the form of IT, so this del Q is this del Q is I into del T, and then I just put this thing into this equation number 1. Okay. When I put in this in equation number 1 and assume thing, this is assumption. This is assumption. So assumption, if T1 is 0, initially the time 0, final time T2 is T. So del T change in time, T2 minus T1, which is T. So electrical energy is E, either you can write H, which is VIT, simply. Now, how from this to this particular box formula comes? Because I write it down this formula same. Okay. So everyone got it? We reach till here, till this particular point. Now using Ohm's law, which is V equals to IR, if you put the value of V, which is IR, so it becomes IR square, I square RT. If you put the value of I, which is V by R, so the formula is going to be V square by RT. And just forget this, because that is going to be separately teach in the next slide. But power we know, energy per unit time taken. That's what I want to teach you here as well, but it's still just focus only on energy, electrical energy. Is this clear, everyone? Like how I get this particular formula, VIT. Sir, why that negative sign unit formula? The negative sign states that that particular energy is going to be stored. In thermodynamics, if you remember, work done is going to be taken negative whenever work is done on the system. And work is done taken as a positive when work done by the system. So this negative stands, or this negative tells you this much energy you need to do. I mean, this much energy you as a system, electrical system, require to perform that particular work. To just convert electrical energy into light energy into bulb, that system requires that much energy. And when the reverse is going to be, like when you already have electricity, or that electricity is going to be changed into light energy, heat energy, any other form of energy, mechanical energy, like the moment you switch on the switch, I mean, you just turn on the switch, the fan is going to circulate. So that particular electrical energy is going to be converted into mechanical energy of fan, and then you get the wind, or you get the wind in general. So that is, then the negative sign going to be automatically reversed. Is this clear, everyone? Clear, everyone? Okay. So that is just VIT, and then using I square RT, V square by RT. Okay. So this is electrical energy formula. If the charge inside the conductor moves freely, I mean, that is, they just wanted to say this thing in a proper way. This potential energy would have gotten converted into kinetic energy, so that the total energy del K equals to del U remains unchanged. During the collision, energy is transferred from these electrons to the ions, which is vibrate more vigorously, and then it then increase the temperature. So change in work done, that is I into del V into D. This del K is converted into del U. SI unit of measurement of electrical energy. See, energy is energy, so that is not going to change. Either it is light, either it is any particular form. So that is another form. So energy E, and that is ml square t minus square. What is where it comes from? Half mv square. If in any particular case, remember this, if any particular case, any particular kind of energy they ask in a question, and you did not guess anything, and you did not know how to solve with the help of dimension. The dimension of electrical energy is always, or not electrical energy, any kind of energy is going to be this one also. I mean this one always and always. This one. Okay, ml 2e minus 2. Another unit of measurement of electrical energy is electron volt. We are going to use this in modern physics. What is modern physics? Where we are going to understand the atom, nuclei, and so and so. Okay, this is also important. Sometimes they ask questions in this, but obviously in JEE Mains sample paper and so, where you already learn the every concept. Electron volt. What is the meaning of that? Again, electron is a charge and volt is a potential. So again, you conclude that particular work which is converted or stored as a potential energy or electrical energy, EV, as simple as that. E here stands for Q, or V is V simply. I mean, V is volt or electric potential to move a single unit charge, to move an electron, to move an electron. Nothing is new here as well. Clear everyone? Is this clear everyone? Is this clear now everyone? Okay, so this is just a representation, written format, nothing new. I already teach you this in the previous slide. Now, electric power. Power is rate of work done, or you can say energy per unit time taken. So that is very easy. Power. That is the concept of 10th class. So if I am running, so don't stop me. Energy per time, or you can say work done per time. So we already have a relation of work done and this potential energy and this electrical energy. So we know this electrical energy is VIT, right? So if I want to know the power, what is the formula of power? Tell me. That is very easy, guys. Tell me. From here, at least tell me. Unless I have to go in some pond, I have to die in the pond itself. Small water pond. What is the formula of power? Anyone or everyone, just write it down. Okay. This is power is the rate of work done or energy per unit time taken, the amount of energy dissipated in the form of heat. When electric current is passed through the conductor, that is known as power, energy per unit time. This heat dissipation is called power loss or ohmic loss because these losses are due to resistance offered in conductors. What is written over here in this line means whenever we have any particular ohmic material or ohms or resistor. So whenever, I mean from the resistor, the current is passed, so we know the property of a resistor is to oppose. And whenever something is going to in the opposition, so there is a heat generation. Why? Like in general language, we also say na that is going to be heated up. Heated up means in your school, in your surrounding, when someone two gang is going to fight, so there is a heat up moment. That particular class fellow of yours slap to another, and the heated movement or the heated argument is going to be. Why do you use that word? Heated. From where it arises? And see, everything is related to your surroundings or simple things. You use, you do, you have seen in this. See, you need energy for it. That's what you say. And also, no, the correct word is this, but if you are not energetic, so you go get beaten up easily. See, this heated movement in the physics, in general psychological terms, we say that heated movement because there is a strong, or you can say argument, or sometimes abusive, and then the slap, the fight is going to be done. But here for this particular concept, why we use this word? Because okay, just give me a minute. See, this is your conductor, and in conductor the flow of electrons is basically known as electric current, and they're going to be collide with each other. So obviously, if two people, in general, you can understand, if two people collide, or two some material or two particles is going to collide, so the energy of collision is going to be spent little bit, not accurate or not proper, is going to be converted into heat energy. Simple thing you can understand. In winters we do this in general. Why? But in, I mean, and then there is a heat generation. So what happening here as well? Like we do the work in rubbing our hands, and when we are rubbing our hands, we provide some work. So this particular work is converted into heat energy. Simple thing when we apply. When we apply any particular cell battery to this particular kind of connection, okay, suppose this is your wire, so this is your cell or a battery. So this particular battery, what it does, this particular battery is forced. This particular battery is forced to do the motion of electrons in one direction, and then this is known as your electric current. But obviously they are going to collide with ions and so and so. So there is a heat production in wire as well as in conductor as well as. This is suppose your conductor, and this is suppose your wire. In both the things, is this clear? Due to the collision, simple. So this is written over here. This heat is dissipation is called power loss. I mean, obviously power is going to be lost, or ohmic loss, because the losses are due to resistance offered in conductor. So due to the resistance, due to this opposition port, due to this opposition port, you see the power loss. Is this clear, everyone? Clear? Okay. Okay. So what is electric power? Work done upon time, VI. We already discussed this thing, and that is the concept of class 10. So it's okay. Using Ohm's law, V equals to IR. These are the three important ones. If it is okay, see, one is, even if it is the concept of class 10, but still it is very, very important. And you are lucky enough if you get the question from this. But still, if you get the question from this, so not a simple question you get a little bit complex or moderate. Okay, everyone. So the simple formula VIT, H equals to I square RT, V square by R T, and then VI, I square R or V. This is simple formula you need to use. But how to use? Let's see that. Maybe the next slide is. Also, then I don't know why. Yeah, this is your question. So try that, and if you are not able to do that, so but I want you to try first. Okay. So try this one. Explanation why whatever it is written, an electrical power line having a total resistance of this. Okay, this is your total resistance, delivers 1 kilowatt at this. The efficiency of transmission line is approximately. Total resistance this deliver efficiency. Efficiency is what? The meaning of efficiency? Input output upon input. Simple. Meaning of efficiency is there is a power loss due to this conductor. Sorry, due to this resistor. So efficiency is nothing but power. Efficiency of power line is power divided by power plus power of resistor. I mean power loss in the resistor. Okay. Efficiency is what, beta? Total power. Efficiency. Should I write that much? Efficiency, which is symbol of this. output power, which is the efficiency of a transmission line, means power at this, and total power, which is power plus power at transmission line. So that you need to tell me. So tell me which is the correct answer, A, B, C, D. Okay, so what it is given, resistance is given, power delivered by the power line is given, and the voltage is given. So first of all, you need to find the current through the power line with the help of P and V, and then power loss in the resistor due to this current flowing in the power in the transmission line, and then power transmitted or power loss at resistance. Okay, so you think so? You need to find this and tell me the answer. Easy one this is, if I'm not wrong. Easy one. See, I'll tell you again. This power is the power of a transmission line. This P, you need to find PR, power loss. Okay, I'll explain. Power loss at resistance due to this current. Okay, and how you can find that? You can find easily with the help of this, with the given data, obviously. See, questions like this they ask in JEE Mains sometimes, if you are lucky enough. Everyone got C? Okay. So instead of wasting, I'm not saying this. Yeah. So C is the correct answer, and how we can get? See, that is very easy. Given total resistance of an electrical power line is R, which is 2 ohm. Power delivered by the power line is 1 kilowatt, and the voltage applied across the power line is this 220 volt. So to find the efficiency, we need efficiency is P upon P plus PR, power loss at resistance. So we need to find current first, I, which is P by V, and then power loss in the resistor is this, and then on the next page efficiency is P plus P divided by P plus PR, and that is 1000 divided by 1000 plus 1, I mean this is, and then this is your efficiency. Clear everyone? Or do you have any, anyone have any question? Sir, can you show the last slide? Yeah, why not? See, this is the power loss in the resistors, PR. Okay. Good. Try this one. This is, yeah, they ask, this is maybe some 2022, sorry, 2020 or 2019 question. JEE Mains question this is. I didn't write, I don't know why they don't write, but I know this. This is from the JEE. An electric bulb rated for 500 watt at this is used in a circuit having a 200 watt supply. The resistance R that must be put in series with the bulb so that the bulb deliver that much watt is. You need to find the resistance. Simple. Okay. So resistance of the given bulb you find first, and obviously that is the easiest one. But answer is given. Okay. Yeah. If you understand the language, so then it is easy. The language is an electric bulb is rated at, I mean that is the power of electric bulb. Maybe you buy any particular LED or bulb saying that 20 watt, 0 watt, 100 watt. So that is the this. Okay. which is working on this watch volt. So is used in a circuit having a supply this. The resistor R that must be put in series with the bulb of in the bulb so the bulb delivers that much watt. So you need to find the resistance which is need to be put in series. C. Why not D? Tell me why not D? C is the correct answer, but why not D? Okay, for the next thing, in series, there is a division of, if I'm not wrong, current. Yeah, I know this. And in parallel, there is a division of electric current. What is the meaning of saying that? Suppose this is your bulb. I'm not good in drawing, but still I try. This is your bulb, and this is your resistance. So in series, the voltage remains same, V, not V1, V2. That is going to be I1, I2. In parallel, I say something wrong. Wait. In series, voltage is going to be divided, V1, V2. In parallel circuit, current is going to be divided. Yeah, that is the current. And we're going to use this. Okay, R1, R2, R3, I1, I2, then I3. Okay, so using this concept, the C answer is going to be, this is your watt, this is 100 watt here, and RV. We find the RV first, the distance of the given bulb, which is V square by P, which is 20 volt. To get 100 volt out of, C, this is V1, this is V2, because this is 200. Okay, so if at bulb we have 100 volt, so how much we remain at this particular resistance? Only 100. So to get 100 volt out of 200 across the bulb, R equals to RB equals to this much. Or even with the help of this formula, P, which is 500 watt at resistance, and V, which is 100 volt at resistance. Again using this formula, P equals to V square by R. R equals to V square by P. We get the same thing, which is 20. That is written over it. Is this clear, everyone? Meaning of saying that we have here 20 volt cell or a battery. Suppose this is cell or a battery. Okay, and then with the help of, because in series, that is going to help out. In series, we're going to divide the potential or potential difference or voltage in general, or in parallel we're going to divide. We are not going to divide, but in general that is going to be visible, and that is why in electrical. So why? That is why I teach you this, because it is divided. If it is not divided, so it is going to be maybe 80 or something else. Okay, this is the reason. Because voltage is divided. So already we use 100 volt here, so we only have 100 volt, and we given in the question we need to keep up 500 watt here. So when volt is same, this power is same, so we have the equal resistance as equal to the resistance of a bulb, because everything is same. See, this volt is same, voltage potential difference is same, electrostatic potential is same, and this watt is same. That is why. Clear, Josna? Okay, So this is your resistors and resistance. So you know resistor what it is. Resistors are electrical device that restrict the flow of electric current in a circuit. Follows the Ohm's law. V equals to IR. Current flowing through the circuit depends on the equivalent resistance of the combination. Two types of basic combination, like there are a combination of resistors, two types: series combination and parallel combination. Okay, series combination in which resistance are connected end to end. That is known as series combination. In general, series combination and parallel combination very easy. You can correlate, you can make an analogy with the help of your ground or with the help of your assembly point, because you are in school and I know you are going in school right now also. So in your assembly hall, your class section is aligned or standing in a queue which is in series connection. What is the meaning of that? This is you, behind this is your another class fellow, behind this is one, behind this is one. So if you people just put your head on the another shoulder, I mean, yeah, what I'm saying, yeah. If you put your head on the shoulder of your front class fellow, so then what it is, beta, then it is a series combination. But another section, suppose this is your 12th A or B or C, whatever section you are. Now this is your another section. Okay, and this is your another section. Suppose you have three sections. So first of all, if you understand easily or quickly what is the meaning of series and combination, then you are easily understand here also. So now these three rows are connected. If I'll connect, because this is 12 ABC, 12th class it is not. So this 12 ABC, if they hold the head each other also and in the same way, okay, like this only, not the each student but this much only. So now they are connected in parallel, because this Q, or you can say Q1, which is the row of class 12 section A, is parallel to Q2 and parallel to Q3. One another example you can find, whenever you go in any particular mall or hall or somewhere where you need to be in queue, for example, buying the ticket of any particular movie, or to be in the queue of McDonald's or any particular pizza outlet. So there is one queue, there is another queue for orders, then there is a third queue for the payment also. Okay, so one single queue is the example of a series combination. Okay, and this whole is the example of parallel combination. Clear everyone? In the same manner, if I attach my resistance, I mean in the next page, if I'm not wrong, they make the beautiful diagram also, but this is your R1, R2, R3 in series in between A and B. Okay. And this one, let me change the color. Just with the help of 3, I can teach you. They can be any other instrument other than this. Resistance is nothing but instrument, simple as that. It can be, okay, let me write it down. It can be bulb, it can be torch, it can be any particular simple thing also. Why should I choose this? Suppose this is your potential. This is, yeah, I1, I2, I3, R1, R2, R3, parallel circuit or parallel combination. And this is your V, and this is your I. So I remains same. This is your, let me draw here, V1, V2, V3, and just by using this V1, V2, V3, I1, I2, I3, we can find the parallel combination or series combination. Is this clear, everyone? Is this clear? Okay. Yeah. So resistor in series mathematically this. Okay, let's. I want a break, right? Because I'm speaking since last 2 hours, so 2.5. So let's take a break of 5 minutes, 5 to 10 minutes. Write this thing, whatever I teach you, because analogy or when you correlate with the when you correlate with the real life example, so then you can easily understand. I need a break personally, 5 to 10 minutes. You guys also take a break because maximum thing we done in this class. Now we only have a combination and then EMF and then what is cell, just introduction of cell. And there is a question in class assessment and homework question are really good for example this. Okay. So there is a 5 to 10 minutes break. Just exactly after 10 minutes, I'll. Hello, hello, hello. Am I audible? So let's do this quickly and then focus on the questions. Okay. So this is easy mathematically resistance required or equivalent in series combination because you already know where from it comes. The derivation is not going to us because it is related in the CBSE. So if still you want to know, V net is nothing but V1 plus V2 plus V3 plus so and so. V net is I because it is remaining same R equivalent or R net total I R1 plus I R2 plus I R3 plus so and so. Taking I common, R equivalent is R1 plus R2 plus R3 plus dot 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 Rn. You can say till n. Here Is this clear now? That is nothing need to explain more, because that is omitted or deleted from the CBSC. So they don't ask this. We just need to focus here. Hmm. Even they explain. Okay. Wow. Good then. So this is V equivalent, V1 plus V2 plus V3. As we know, I equals to I1 plus I2 plus I3. Current remains same in each resistor in series combination. V equivalent is I equivalent using Ohm's law. We get this, and then moving ahead, resistor in series I this is. I don't know why. Okay, maybe the proper explanation they want. Or this is going to be this. Just a minute. This is a circuit diagram. Okay. So beta I remains same as you can see, and this V1, V2, V3 is going to be separated. Clear everyone? I is remaining same here. I. Clear na everyone? Or you can write it down or as a note. So you can find in series combination, in series combination, current remains same. Current I remains the same. Current I, yes. Okay. This is in parallel. So this is just formula. Maybe they also explain this. So in parallel combination, as we know, I equivalent. Okay, here you can write a note also. In parallel combination, voltage V remains the same. Okay, voltage V remains the same, so that is why I is going to be that is why I is going to be the divided into this kind I1, I2, I3. So using this simple technique, I equivalent is I1, I2, I3, and then I equivalent is V by R equivalent. So I1 is V by R1, I2 is V by R3, and then simply adding down in this way, because as I already described this thing, so still I1, I2, I3, and that is obviously this I1, I2, I3 originated from this simple I. So this I equivalent, or you can say total I, is I1 plus I2 plus I3, and from there using Ohm's law, V equals to, V by R equivalent is going to be V by R1, V by R2, V by R3. So this is your formula for R equivalent. Okay, this is example of resistor in parallel combination 1 by R 2 3 equivalent. That is important one. This one. Maybe they don't. I don't know why they write 2 3 in that form. But okay, this is the example of resistor in parallel as well as in series combination. Mixed combination. So in mixed combination, one thing you need to understand, when you need to find R equivalent for two resistance only, 1 by R1 plus 1 by R2. So that is simple multiplication and then simple add. So equivalent resistor or equivalent resistance of two resistors in parallel, that is going to be this one. You use this formula directly. Don't use this simple method of R1, R2, R3. And the same thing they already explained here. Clear? So what is this? This is example of resistors in parallel combination. They mix this thing with series. With resistor in series. Or you can say mixed combination. As you can see, this R2 or R3 in parallel. Okay. How we can write it down? R2 parallel R3, and this is in series combination R1. So we find first of all R equivalent of 2, 3. That is R equivalent of 2, 3. And that is R equivalent of 1, 2, 3. What does it mean? R total is R1 plus R equivalent, where R equivalent is R1, or this is 2, 3 na. So then R2 into R3 divided by R1, sorry, not 1 here, 2 plus R3. That is the net combination you're going to find. Is this clear, everyone? Or I just run very fast? Tell me. Clear na? So the circuit now has R1, R equivalent 2, 3 in series. So if the voltage A, if the voltage between A and C, and the current is I. So remember, always you get so many questions like this. Whenever you get the question from the combination part. Okay, beta? Is this clear? Is this clear? Hari, you are look tense. I mean, like you are not clear. I mean, you are not getting whatever I'm saying. Mixed combination this is. Is this clear, everyone? Is this clear, Jyotsna, Hari Mahesh, Yajiha already, Sudarshan, Parikshit, are you still there, beta? I can hear you.
Sir, can you hear me now?
Yeah.
Yes, I understood, sir.
Sorry?
I understood, sir.
Okay. Now you introduce yourself. Go ahead. Then we're going to understand this EMF or this. Introduce yourself. 3 things I want. Where are you from? Which board you are from? And what is your favorite subject in physics? Or you can tell me your hobbies also if you want.
Sir, I am Parikshit, sir. I am from Tamil Nadu, Chennai. I am studying in Shraddha Children's Academy, Kodivakam.
Okay.
Shraddha Children's Academy. It's a
Shraddha
CBSE
Children's Academy.
Yes, sir. What else should I say? I am the CBSE board school, sir. I am studying here for over 9 years. My favorite subject as of now is maths, sir.
Maths.
Yes, sir.
MATHS for mathematics, right?
Yes, sir.
Okay. Any hobby? So if any particular problem we as a class struck, so you can help us out. Integration, differentiation, vector algebra, calculus,
I
right?
like maths, but I'm not that much into maths.
I'm just joking. What do you like in maths? I mean, as a class student, 12th student, I like the maths also. But I like more physics in when I do my graduation and post graduation.
In 12th, I like the topic matrices.
I want to ask generally this because this same line I am going to say in the front of NEET batch because someone is like math, so why he or she like math? So I can tell them, so they also like math and get some marks in physics, specifically when they need to solve numerical. Tell me, what you generally like? That's it. As a student perspective, as a student point of view.
Student in studies or like what, sir?
See, what I like in my maths in my time, I don't need to learn anything. The same thing in physics. That's why I don't like chemistry.
For me also, it's like the same only, sir.
Even I can solve the maths or numerical problem just plug in the earphone and listening my favorite songs. I can do that. You cannot do the same thing in history or in chemistry.
Yes.
Why should I say history first? Because there you need to learn more, like the dates, places, names of so many things. Okay. Okay. So this is cells and EMF. What is a cell? You know, singles, potential or a battery. Not battery. Simple electric cell. Cell is an instrument in which the electrical energy is going to be converted into the electrical energy. Should I repeat the same thing? Chemical energy is going to be converted into this. Okay, this is your look like cell. Simple. You can say power cell or cells which you use in your remotes or in your clocks. Okay, so what is inside it? When the used cell try to break this used cell, you're going to see something black inside. That is nothing but that is graphite. Graphite is a good source of conduct. It is a good conductor basically, and this graphite, this is basically the chemical. It is change its chemical energy into electrical energy. Simple. That is your cell. Okay, is this clear? So now come on the EMF. EMF, electromotive force, is a potential difference which is created when no current is flowing in the system. What is the meaning? Like simply in a simple sentence, EMF is nothing but the resistance of a cell itself. Is this V equals to E minus IR? This R is the resistance of a cell in general, but EM is the potential difference which is created when no current is flowing in the system. What is the meaning of this? See, there is positive potential, okay, there is negative, there is the positive side anode, this is negative cathode. So the difference between the potential at this particular point, now what is the meaning? Suppose there is a reference point, any particular reference point, we choose this A or we choose this B. Okay, so to move charge from any particular point to this reference point A, this is potential A, and to this particular point B. So the difference between the potential at B and the potential at A inside a cell where current is not flowing in the wire. Okay, current is not flowing in the circuit. That potential difference is known as EMF. Is this clear, beta? Someone asked me like EMF and this potential difference. This is a, you can say, potential difference for a special case where current is not flowing in the circuit. That particular potential difference is known as EMF. Clear, everyone? Clear na? I think this Noel asked me this question, or maybe Sayed, or maybe Trivita. Okay. Is this clear, everyone? Like EMF is a potential difference which is created when no current is flowing in the system. Where internal resistance, what it is? Internal resistance is the inherent resistance of the cell. Internal resistance is the inherent resistance that is present inside a voltage source. Any particular source, we are talking about cell right now. So we are talking about cell. This R, small r, is internal resistance or resistance of a cell or a voltage source. Clear, everyone? That is nothing more to explain this. Terminal voltage, that is important. The net voltage developed across the terminals of the battery is given by the equation written below. V equals to EMF minus EIR. What is the meaning of this? See, this particular voltage, this is the EMF E, this is R, and this voltage is going into any particular load which is going to flow the current in general also. Okay, which is going to flow the current in general also. And instead of one, I can attach two. Instead of one load, just give me more. One instrument, I can attach. I can attach this one also. This is suppose your capacitor, and then this, and 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 this. Now what it is? It is your resistance. So now I have two loads. So again, this is your voltage, this is current, and this voltage is going to be divided as we know already in series. So the net voltage developed across the terminals of a battery. What is the main terminal of a battery or terminals of this? This is your battery, including the internal resistance also. Okay. V equals to EMF minus IR. Okay. So this is your net voltage driven or given to the circuit. V equals to EMF, where current is not flowing, potential difference of cell of a battery, and minus IR. The R equivalent resistance of the circuit becomes then total R plus R load. What is the meaning of R load? Whatever the circuit R load have. Now R load have this RC plus R because they are connected in series. So the resistance of a capacitor, RL stands for R load. Okay, plus R, or you can put R1. So this is the R load. Clear, beta? So that is your R load. So total resistance R of a circuit, total resistance of a circuit becomes R plus R load. In general, that is always internal resistance is always or maximum number of times connected in series. So the current is given by the Ohm's law, which is I equals to EMF divided by R plus R load, because net resistance or total resistance in a circuit, net resistance in a circuit, CIR CUI in a circuit is R total, which is again this RC. Okay, I just write RL plus internal R. Here, everyone. Simple basic things. And even this combination is going to be complicated, like circular, triangular, so many things. Okay, is this clear, everyone? In general, EMF is nothing but the work done or potential difference, because potential difference is treated as a work done del Q by Q, del V by Q, work done, what I'm saying, yeah, electromotive force is nothing but the work done by the cell until unless that cell is not going to transmit or transfer electric current or going to flow the current in a circuit. Clear everyone? This is better clear?
Yes, sir.
Okay, simple. So now, okay, let me check. Okay, this is your practice question. The supply voltage to a room is this. The resistance of the lead wire is this. A 60-watt bulb is already switched on. What is the decrease of voltage across the bulb when a 240-watt heater is switched on? Sorry, in parallel to the bulb. Read this question twice, and what you understand, let me know. Then I'll let you know also. Sorry. You have given the resistance of a bulb, if I am not wrong. Okay, not given. Supply voltage to a room is this, the resistance of the lead wire is this, okay, and a 60-watt bulb is already switched on. Okay. What is the decrease of voltage across the bulb when a 250 volts? Oh, that is easy. Okay, so I will just explain the diagrammatic problem. Suppose this is your case 1. In case 1, this is your wire and the resistance of a wire, and bulb. This is your bulb. They are connected in this way. This is your case 1. Okay, and obviously this is connected with some battery voltage. In this way, this is your case 1. In the second case, when this is not I, case 1. In the second case, the same thing is going to be, but now you have this bulb. P equals to V square by R and then V1 and V2. Is it correct? Yes, it is. Then this is something which is 240-watt heater is connected in parallel in this way. And this is this. Okay. And you need to tell. Okay. So what is the decrease of a voltage? So I draw the diagram. If anyone try to solve that and able to solve, so let me know. If no one, so I'll. So obviously, because this is now only 2 instruments are connected. Now we have 3 instruments connected. So there is a voltage difference. So you need to tell me the difference in voltage, decrease in voltage. See what happens if this particular voltage is going to be, obviously voltage is same in this bulb or in this, but still due to this resistance there is a power loss, there is a voltage also in here. So what is the voltage difference in the bulb in second case due to this application? Tell me. Tell me, beta. I'll just give me a moment so I can think about it. A, B, C, D, or anything. Anyone, please? We don't have that much time. I think I have good amount of question. Wait, how many here? One. After this, two more. Yeah. D. Nice. Why don't you other guys solve this? In the last class, if I am not wrong, I tell you to take a charge or solve as soon as possible. Is it correct? Yeah, I hope so. Yes, beta, it is correct. See, you need to learn this thing, each particular individual I am talking right now. Whenever any particular question is given, so mark the given things, try to imagine what is saying in that question, try to diagram, make a diagram this, and then try to solve as soon as possible. Obviously, in doing so, you are going to do the lots of mistakes, believe me, but that is going to help you out. Okay, so don't hesitate and don't frighten like you are solving something wrong, because initially in the first case, whatever thought comes in your head, if you are clearly understood the concept, that is correct. Overthink that going to harm you in each particular case. So that is your case number one. Already I draw that. That is your case number two. Okay, so R, resistance of bulb, first of all we are going to find out. That is what it is. Okay, V square by power, if I am not wrong, because power V square by R. So R is V square by power, which is 240 volt. So then V1, this V1 voltage here, 120 divided by 246, because 240 plus 6 into 240, because that is your resistance, and that is your, what is this much only. This much is the current beta. If someone is not understanding, so that is current. What is V net upon, sorry, I'm doing V net instead of V upon R. Okay. Or you can take this R as a simple resistance or resistance of a wire, which is also included as a resistance of a internal resistance of a battery. So then you can find V1 in the same way, resistance of heater, which is 120 upon. So yeah, this is 60. So V2 is this 120 divided by 54. And now here, how we can get this 54? Tell me, this R net is this parallel combination, which is 240 into 60 divided by 300, and then plus 6. Okay, this 48 plus 56, which is going to be, this is going to be 48, and then R is in the series, so 6 plus 48 gives you 54. But I want only and only my voltage here, which is going to be remain same, or R23 equivalent. This is 2, this is 3. Okay, so that is going to be 106.06, and then change in voltage. That is going to be change in voltage. V1 minus V2, because it is high, it is low, so you can find it. Is this clear, everyone? Is this clear, everyone? See, this is the just practical example of whatever we learn in the mixed combination. Clear? Initially we have this only, which is in series. Now I attach one more in parallel. So this is going to be 2, 3. So first of all, you need to find R equivalent, which is R2 into R3 divided by R1 plus R. Okay, again I write R2 R3, and then this R equivalent, which is R net, is 6 ohm plus R equivalent. The same thing I do here directly, but this is your R equivalent. And this is your R total. Clear? I hope and I believe everyone get this solution and know how to solve this. Moving ahead, the potential difference between the terminals of an electric bulb is 30 volt. When it draws a current of 6 ampere from the source, what current will the bulb draw if the potential difference is increased to 120? That is the easiest question you can solve this. I don't believe you need options in this, and that is why I don't give you. Using this simple thing which is Ohm's law, you can find it now. Okay. One hint I can provide you, resistance remains same. $60 ampere. Okay. Everyone got 60 ampere. Let me check with that. I don't know the answer, to be honest. How it is going to be 60 ampere? Yeah, beta, how it is going to be 12 ampere also? This is very basic and easy question if I am not wrong. I give you the solution here in the one line. Using Ohm's law, when I am not changing my using Ohm's law, when I am not changing my temperature, the material, V equals to IR. Case number 1, V, okay, let it write in this way. V2 equals to I to R. Why say R only? Because I am not changing my material, I am not changing the temperature, I am not changing anything. Divide both the equation. What I want? I2. Put it here. Yeah. This is very basic. It's okay, it happens. Confusion is always there. Is this clear, everyone? Darshan, Shrutika, Yajira, Shayad, Roel, Sudarshan, Parikshit, and Kritika. Everyone. I don't need to take the name. Clear, everyone? I took the wrong values. It's okay. It happens. Okay. See, given that the potential difference of the electric bulb is V, which is 30 volt, the current I. So first find R prime, which is resistance. The increased potential difference R prime is 120 volts. So Ohm's law formula calculate resistance RV by I. R remains same. And then this 24 ampere. Okay, try this one. Here I need to tell you one thing because that is required. There is a concept known as Wheatstone bridge. Wheatstone which we're going to understand, and that is you guys going to use here as well. What is the meaning of that? What is Wheatstone bridge? I just give you a quick wrap. Suppose there are 4 resistors in this way are connected, because you need to use that thing. That's why I'm going to give. Even you're going to use maybe here also. If it is not, so it's okay. And then there is any particular resistance or any particular instrument is here in between. Suppose there is a resistance. Suppose resistance or any particular instrument, I am also saying that. Then there is this, and then there is. So if I'm not wrong, P, Q, R, S. If PQ equals to RS, means the ratio of, if P by Q equals to R by S, then this in this condition, in this condition, suppose this is your A. In these conditions, current at A is 0. Okay, we have a proof, proper proof, but that proper proof you're going to see in next week Tuesday class. Okay, so this is your Wheatstone bridge circuit that is going. We're going to use that thing a lot in the coming classes, or specifically in your homework, you're going to use that a lot. So now, how you're going to use here? As you can see, this is 2 by 2, this is 2 by 2. So the current here at this or this is going to be 0. So now easily you can find the current in between A and C. Is this clear? Is this clear, everyone? Or should I repeat? Clear, beta? Or this is your Wheatstone bridge condition, special one. Okay, so what is the meaning? See, I explain you guys again. If P by Q equals to R by S, in this condition, current at A is 0. At A, you can put anything. Anything means anything. So, following this condition, as you can see, suppose AB divided by AD, 2 by 2 equals to BC divided by DC, 2 by 2. So, in this particular condition, the current here only at 5 omega at 5 ohm is going to 0 only and only, not this. So now this circuit turns into a series connection of this 2 and this 2 with the series connection of this 4 and this 4 with the series connection of this 4 and this 4, and this combination of AC, combination of DC, and this is going to be attached in parallel. Okay, just one for you guys. See, this is directly given, but it is going to be converted in this way. Wait. This is R equivalent. This is, okay, I'll attach in the same way. 4, 4. I need to take the shapes. Just a minute. Okay, this is the converted thing. If I'm not wrong, this is your 8-volt battery. This is the current I. Now you need to find the this thing, R equivalent or R total. So R total is nothing. R equivalent, because this is in 3, so you cannot do directly. 1 by R equivalent plus 1 by 448 plus 1 by R equivalent. And R equivalent, if I am not wrong, nothing, 2 and 2, 4. So let me write it down here directly. 1 by 4, 1 by 8, 1 by 4. Okay. So I1 is nothing but 8 divided by 4 plus 4. 4 plus 4, yeah. 8 voltage divided by 4. Okay, then the parallel combination of this 2 and 2 is going to be 2 into 2 divided by 2 plus 2. Something is missing. Wait. This is 4 divided by 4, which is 1. Okay. See, what is the assumption? Not assumption, what is this? See, the current in this and the current is this is going to be 0. Why so? Because using the concept of this Wheatstone bridge, if current is not passing through this, so obviously current is not going here as well. In the same way, if current is not passing through this, so current is not going here as well. So simply the current I1 in the branch AC I1 is 8 volt divided by simple. I mean the current here is 0 and 0. And we have only current here, which is I1. And then this is 1 ampere. Is this clear, everyone? Is this clear, beta? If it is clear, everyone, or you have guys doubts? If it is clear, so you can try this test, and if it is not, so I can tell you again. Tell me, everyone, because after that there is a summary, nothing more than that. You don't need to find this here. Can you explain again, sir? I'm telling using the concept of Wheatstone bridge. Okay, wait. See, as I already discussed this thing, when this and this is going to be equal to this and this, the ratio of 2 by 2 is equal to the 2 by 2, right? This is 2 by 2, this is 2 by 2. So the current here is going to be 0, and here as well it is going to be 0. Only and only the current here is going to be 0 when the current in this circuit is 0. The current in this circuit is 0, in this wire or in this wire also 0. So there is no current flowing in these wires. The current only and only I1 we have, simple, in the given circuit. Clear? Should I explain it again? Means using the, okay. Wait. Using Wheatstone bridge condition. I2, this is your suppose I2 and this is your I3. We have only this I1, which is okay. I2 equals to I3 is 0. So we have only I1, which is 8 volts of this, and the resistance 4 plus 4, which is 1 ampere. So the correct answer is D. Is this clear now? If it is clear, so that's done by my side. This is the summary. What we learned in this class: electrical energy and power, combination of resistors, series and parallel, and cells and EMF, and internal resistance, and few important questions.